Now, instead of brain emulation, there are several technologies that could be used in trying to create a copy of the brain. 3D printing is one of the most often mentioned. Another method involves sending nanorobots into the brain to survey neurons and return sufficient data to create a 3D map. However, these technologies, like many others in the field, are well underdeveloped and incapable of coping with the complexity of the brain. So, in reality, none of this is considered a realistic method of emulating brain activity. The problem goes beyond our inability to map all the elements in the brain. There is also the fact that all those elements interact continuously with each other with no specific pattern. Basically, this means that any scanning technology would also need to be able to capture and replicate these interactions as well, and do so in real time. Look, the truth is that most scientists in the field do not believe that human-level AI will first be achieved through brain emulation. In fact, Nick Bostrom concludes, I quote, "The emulation path will not succeed in the near future because we know that several challenging precursor technologies have not yet been developed." So, in simple terms, thinking of Google's RankBrain as a human brain will not tell us much about how Google will achieve its AI goals. This means that we are left with the second path, which is machine learning. In super simple terms, machine learning is the process of creating algorithms that are able to learn from the data fed into them without them being programmed to do so in detail. Stuff like recognizing cats and dogs in images in spite of the image not being optimized is one example. As opposed to the human brain, which can quickly learn what a cat looks like, an algorithm has to be fed with quite a few images of cats to categorize what a cat is. Once it learns the characteristics of a cat, the algorithm starts a continuous process of trial and error until it reaches a conclusion of what is and what isn't a cat, basically what a cat looks like. Let's just consider an example of Google feeding its algorithms with millions of images of what it believes to be a cat. Let's assume as well that Google generated these images from various sources, including the alt text or file name provided by SEOs. Let's also assume that you optimized a Shutterstock image of a cat, while another SEO purchased the same image but did nothing to optimize it. RankBrain now monitors responses such as click-through rates, time on site, text around the image, and so forth against user queries for cat images. And if the metrics indicate that your image does have a cat in it, the metrics will assume the same for the same unoptimized image. You now have an image that is being labeled by RankBrain as a cat in spite of having no alt tag or other optimization performed on it. Of course, let me emphasize that this explanation is a gross oversimplification. In fact, image recognition is already a commodity, which is testimony to the advancements in the field. For example, Amazon's recognition service makes it easy to add image and video analysis to your applications. You just provide an image or video to the recognition API, and the service can identify the objects, people, text, scenes, and activities, as well as detect any inappropriate content. Amazon recognition also provides highly accurate face analysis and facial recognition. You can detect, analyze, and compare faces for a wide variety of user verification, people counting, and public safety use cases. Of course, Google and many others already provide image recognition and analysis as a service too. We'll stop in here and we'll complete the conversation in the next session. Thank you for watching.